opening down would look like this, right? Below the x-axis opening down would look like that, yeah? Above the x-axis opening down would look like, I don't know, here. I'll put it here. Right? So, and again, we can call that R1 and R2. So how do we, so what I'm trying to get at is, to really understand geometrically what the parabola looks like, we need to know where the vertex is, right? The vertex is really a lot of it. Other things we'd like to know about, where are the x-intercepts? Are there x-intercepts, right? Another thing which characterizes the parabola is its axis of symmetry. What's the axis of the symmetry of these parabolas? Where does it go? It's the line, vertical line, right, that goes through the vertex, splits the parabola in half, right? There's an axis of symmetry for each one of these. So how do we find those algebraically? Well, here's how. So if we have y equals ax squared plus bx plus c, what we're going to do, factor out the a. Right? Factor out the a, complete the square. So what we got is a times x plus b over 2a quantity squared plus a times c over a minus b squared over 4a squared, if I just flip those two terms around. And so what I have is a times x plus b over 2a quantity squared. And when I multiply that out, I get c minus b squared over 4a, I believe. So this tells me a lot, actually. See, because if you think about the parabola, right? I said that the vertex is at h comma k, right? So if I think of this thing as f of x, right? If I think about this, my parabolic function, this thing right here as f of x, okay? Think about it as a function of x. What should f of h be equal to? F of h is what? F of h should be the output when you're at h. It should be what we're calling k in these graphs. Right? So whatever this k is, it should be f of h. But what should h be? Can you think about this? What do you need to do to the formula to be at the vertex? Where is it? It's where the formula is either biggest or smallest, right? That's exactly when this squared term goes away. How to make the squared term go away? You need x equal to what? Minus b over 2a, right? So if you think about this for a second, you can see that h should be equal to minus b over 2a. So where is the vertex? Where is the vertex for a parabola? It's at minus b over 2a. And where's k? What's the k value? What happens when you plug in this into the formula? Well, from what the line of algebra I have right above, it shows you the formula for the y-coordinate of the vertex is straight up c minus b squared over 4a. So here you go. That's a formula for the x-coordinate and the y-coordinate of the vertex of a parabola in terms of the coefficients of the parabola. We already found a formula for the x-intercepts, right? What was that? What is the formula for the x-intercepts? So r1, you could say r plus or minus equals to minus b plus or minus the square root of b squared minus 4ac divided by 2a, right? This is the quadratic formula. What I'm suggesting is we could realize that well, I'm saying plus or minus, but this is going to be what I've called R1 or R2, right? And my labels over here. And that quadratic formula answers the question, when are you above or below the x-axis, right? Like, just think about it. B squared minus 4ac less than 0 implies vertex, you know, above or below. Well, that's not the way to say it. If that's less than 0, that means that there's no x-intercepts, okay? No x-intercepts. Let's look at some examples with numbers in them. This is the general formulas for the thing, okay? There's some other things to notice. What happens if you add r plus to r minus here before I get to my example? One other thing, r plus plus r minus, what is it? What happens when you add the roots to the quadratic formula? You notice that the plus minus term cancels out, and you're just left with minus b over 2a minus b over 2a. In other words, you get minus b over a. If you wanted to calculate the arithmetic average of two numbers, how do you do it? What's the average of 3 and 7? What do? You do 3 plus 7 divided by what? 2, right? 3 plus 7 is 10. 10 divided by 2, 5. 5 is the average of 3 and 7. So to calculate the average of the roots here, you do r plus plus r minus divided by 2, and that's equal to minus b over 2a, which is to say that the vertex will be at the average of the roots. If there are x-intercepts, the vertex is always halfway between them. That's really nice to know, right? And something interesting is that formula is still true. That formula is still true even when the roots are complex, because they come in a conjugate pair and they cancel out. But, all right, so some examples. As is the case here, I think we're example what, 8, 9? Can't remember. Is it example 8? I feel like 8. Am I wrong? Here we go. Y equals to x squared plus 3x plus 2. So here, I can complete the square. And let's see here, x plus 3 over 2 squared, that's minus 1/4, right? So I should mention that, theorem, if you like. If y is equal to a times x minus h squared plus k, then vertex at h comma k. So if I take the parabola and I complete the square, right, then from this I can see that the vertex is where? It's apparently, for this one, minus 3 over 2 comma minus 1/4. Let's see here. So now what else can I do? There's a lot more theory we need to unpack here. Probably more than we have time for today, but let me just kind of show you another thing we can do here. We can factor this, right? And if you factor it, what can you see from that? From the factoring, you can see, aha, well, this is 0 at minus 1 at minus 2, right? So it's got x-intercepts of -1 and -2. And apparently its vertex is midway between those at -3/2. Yeah? What else can you do to add some substance to this graph here if I was doing it better? Where's the, my bad. So this is -1, this is -2. If I try to keep with the same scale, 2 is about right here, yeah? What's the y-intercept of this graph? So it's right here, right? C2 is the y-intercept. If I plug in 0, I get 2, right? So this is the graph like that. And the vertex right here is where? It's at -3/2, -1/4. Now, you're like, well, I don't want to complete the square. It's scary, and I'm tired of it. I would rather use formulas. Well, if you must, try these formulas out, see if they work. What's h equal to? Minus b over 2a. What's b here? It's 3. What's a? A is 1, right? Minus 3 over 2? Great. What's k? c minus b squared over 2a, right? 4a, rather. So what's that look like here? If you believe my formulas. C is what? C is 2. B is 3, so that's 9 squared. Rather 9 over 4. In other words, you got -1/4. See, what these two formulas are doing, right, is they're doing the completing the square arithmetic for you, is what they're doing. So you really have two options here for an example. You can consult these formulas to find the formula for the vertex, right? Or you can just complete the square and see it right there. How do you find the x-intercepts? You can go to the quadratic formula and find the x-intercepts, right? But what is a way, way better thing to do in this example is to factor it and read the x-intercepts off the factored form. See, because if I have this tells me x-intercepts of -1 and -2. So yeah, I could have used the quadratic formula over here to find that, but why would I do that when I could just factor, which would be much easier, right? So one final example for today. Sometimes your professor is nice to you and does something like y is equal to 3 times x plus 2 squared minus 7. Find the vertex. Where is it? Can you tell me? Where's the vertex for this parabola? -7 for what? Which is the blank, comma, blank. I'll take that -7. I'm going to put it over here. That's where it belongs. Okay, that's the y. That's the y in -2. Yeah, -2, -7. And all they're doing is using the theorem I wrote over here. Just pattern recognition. Compare this to that. Identify that the h is -2 and the k is -7. Here's a question for you to think about before next class. What are the x-intercepts? Can you find the x-intercepts for that parabola? See if you can work that out. That's it for today. Have a good weekend, you guys. Sorry I went over.